Okay, let's get started. Welcome, everybody. We are excited to talk to you today about how to master floor flatness and levelness analysis for robotic facilities. So, with the growing demand for efficiency in all aspects of our lives, the use of robotic systems continues to rise as warehouses and fulfillment centers are modernized. Robots are being used to handle a variety of tasks in these kind of modern facilities, including handling materials, transporting goods, sorting, and fulfilling orders. And it's not too much to say that robotic systems really are redefining how logistics and inventory management is handled, making facilities much more efficient. But the use of robotic systems has also led to an increased focus on an aspect of the building that typically doesn't get as much attention, and that is the floor. So, worn or uneven floor surfaces really have an impact on a robot's navigation. It'll cause robots to bottom out, run into each other, and basically cause a lot of downtime. And in fact, I found a alarming statistic that floor-related issues in commercial construction cost $1 billion annually. So we're here to talk to you today about how to accurately and quickly evaluate concrete floors for flatness and levelness. We are from KCI, which is a leading civil engineering firm with offices throughout the country. And we're part of a products team that focuses on developing and bringing to market advanced technology for professionals within our industry. But I'm Catherine Burrell, product manager of our technology and innovation products team, and I'm joined by my colleagues, James Clay, who is the leader of KCI's survey group, and Jay Kwan, our sales engineer. So our goals for this webinar today are to introduce how our leaders use RoboFlat and RoboClean solutions to optimize their concrete floor analysis. We're going to I'll show you a lot more, talk to you a lot more about how RoboFlat and RoboClean can optimize your concrete floor flatness testing. We'll show you a live demo of how easy it is to use these solutions. James is going to go through a detailed demo of the output of RoboFlat and RoboClean to show how our solutions generate output that allows you to quickly find the location of floor failures. And then at the end, we want to leave time for Q&A. We have got the technology experts here who can answer your questions about 3D laser scanning, floor flatness testing, point cloud cleaning, and more. So to get started, I wanted to begin this discussion with a few questions posed to James. He is not only our survey leader, but he was also instrumental in the development of both RoboClean and RoboFlat solutions. James, I'm hoping you can set the foundation for us today by answering a few general questions about the current state of concrete floor flatness and levelness analysis. So here I have a few questions. I'll start with the first one. Can you just briefly describe how many floor flatness and levelness projects you've been a part of in your time at KCI?
Yep, we've completed 400 plus buildings, around 100 million square feet of robotic floor.
Oh, okay. So I know that in your projects, you are using 3D laser scanners. Can you talk to us a little bit more about that? Why do you recommend using that 3D laser technology for testing and analyzing the floors of robotic facilities?
Sure. Ultimately, it's about detail and time. So the robotic facilities that we typically are scanning, they'll be up to 1 million or 2 million square feet of robotic floor that needs to be captured and measured. There's other devices out on the market that profilographs where the surveyor tows this little track behind him, a little vehicle behind him, or pushes it in front of him using a pathfinder so that it runs grids across the floor. But on floors this large, it could take several days. And no one has that time in construction, and we can't spend that much time on the floor because everybody else needs to be there, and we need a clean floor when we're out there measuring. So and so the number one, that is the speed of scanning. We can go in and collect 300,000 to 600,000 square feet of open building floor in a day using the proper techniques and everything with our 3D scanner. And also with a profilograph, you'll collect whatever grid spacing you set out. Well, they might set out a 1 meter grid or a 1 foot grid or 300 millimeter grid, something like that. And that's the only points you get are along that grid. But with 3D scanning, we'll have a point every 5 millimeters or 8 millimeters or so across that entire floor. So now we have a lot more data that we can analyze to provide a much better grinding report analysis for the remediation teams and the owners to use to get their facilities up and running faster, quicker, and better in the end. So that's why we lean on 3D laser scanning.
Okay, that's interesting. So it's not only about the speed of the data collection, but it's also the breadth of the data that you're getting. What this is the next question is something we get asked a lot, and it's really has to do with level of accuracy that can be achieved with 3D laser scanners. Can you talk to us a little bit about that?
Yes. So most of the 3D scanners that are available on the market, they're rated from 6 millimeters to 3 millimeters or so with the laser system. However, that's their standard rating at their standard distance. If you reduce the distance to your measured object, then you can increase that scanning. I'm sorry, they can increase that accuracy. So for us, we reduce our scanning quite a bit to 10 meters apart or something like that across the floor. We don't like to go any further than that, and we'll clip that data off very short. We will not use data over 25 meters or less from our scanner, so that we get rid of a lot of the noise and things like that. So in the end, because we take extra precautions, we scan more often. We also run survey control through all our scan setups so that we run digital levels for a cross check to make sure we're staying within accuracy where we need to be with accuracy for these type of robotic floors. We can repeat 1.5 millimeter accuracy is what we've seen out of our system and our way we approach it. So it's usable. The profilographs are rated to below sub-millimeter readings. However, again, that's with any calibrations and things like that, and a limited number of points that those are collecting compared to how many points scanning collects and what you can do with an analysis of that data. You're increasing your accuracy and your detail and your reporting abilities with 3D scanning.
Thank you. And the last question I wanted to talk to you about was that analysis of the floor. So I know you and your team does a lot of, as you mentioned, floor flatness and floor levelness analysis. What are you looking for both cleaning the 3D laser scanning data as well as analyzing it for to make sure that it conforms to the correct FF and FL spec?
Great question. So number one, in the cleaning side, because there are a lot of other contractors on the floor when we're out there scanning, we will capture their hoses and things like that, lay down gear on ground, and things that'll get within the scan that need to be cleaned out. There's a lot of tools on them that come with your typical scanner with the software that comes with it to help you clean that data. But on a large floor, you can take 10 hours easily cleaning with a lot of noise on the floor, trying to get everything to remove. Because again, we're trying to measure very close to the 1 millimeter deviation on a lot of these testing. And so a lot of automated cleaning that's built into the software that comes with your scanners just can't get there. And so that's a big problem for us. There's just not enough settings for you to do that. So on our end, being able to take a cloud that won't and drop it into a system, a cloud-based system that gives me that results back, while my operator in the office, instead of having to spend 8 hours trying to clean a floor to get it as accurate as we need and get all the noise off of it, they can go to the next project while the cloud is processing and cleaning that data to get it back to us. So that's a big deal. Take it out of our hands, do a better job than what our humans can do in a lot less time. All that is critical for us. And then for the results, we have multiple clients, and all of them have different specifications that they need us to follow. So one, it needs to be flexible for the testing side of it. We need to be able to put in, it needs to be customizable. We can choose different custom settings or built-in settings. There's lots of specifications out there. There's the ASTM 1155 for floor flatness and levelness, and then there's the TR34. There's other types of products out that have their own specifications, such as AutoStore and things like that. So for us, we want to make sure all those things are covered. And then for the output, again, back to the multiple clients, what does your client need to look at? Some of the remediation teams and the owners out there, they love Excel spreadsheets, and just to see all the numbers out in an Excel spreadsheet of the deviations that were found and what was failed and what passed. Others like CAD output, which if you approach the scanning right, the CAD files, when they come back, as long as you tie it into the CAD coordinate system, when those reports come back, I'd like that CAD system to already be established so that I can just drop the results that come back in CAD as directly into floor plans. So now the owner or remediation team say, okay, well, I can tell exactly where these are at. So, and then there's the quick reports. We need some kind of overview that we can deliver to our client to say, we've tested it here. Here's where you're at right this second. Here's a quick overview for the non-technical side that just need to know, am I passing, am I failing? How bad is it out there, or how good is it? So that's what we're looking for on all those.
Thanks, James.
You're welcome.
So that's why we developed RoboClean and RoboFlat. They are cloud-based solutions that provide automation and flexibility for this entire concrete floor analysis workflow. RoboClean is designed to automatically remove floor artifacts from the 3D laser scanning data, and RoboFlat then analyzes that cleaned file and tests it for floor flatness and levelness. RoboFlat supports a variety of floor standards, ASTM, TR34, and also custom standards. So as James had mentioned, for those clients that you might have that have specific requirements, you can specify custom settings using RoboFlat and test the floor according to those specifications. RoboFlat and RoboClean are designed to be very intuitive, providing that automated pipeline that professionals need in order to get the results that to their clients. It's a 5-step process. You capture the floor using a 3D laser scanner, then you upload and submit that raw point cloud data to RoboClean. RoboClean results can then be easily submitted and run through RoboFlat. When you're setting up your RoboFlat run, you can specify very granular tolerances for your analysis, run your RoboFlat test. Remember that both RoboFlat and RoboClean are cloud-based, so very high performance, speedy results. Once your results are done, then you can download them. And this is all from one cloud-based location. So something that usually is a tedious, multi-hour, multi-step process, something that takes days, can take a matter of hours using RoboClean and RoboFlat. So now I wanted to show you all, this is probably one of the best parts of our presentation. I'm going to give you a quick demo of exactly how easy it is to use RoboClean and RoboFlat. Then I'm going to pass it over to James, who's going to go over our output. So to get started, you should see here, I've logged into our platform, and RoboFlat and RoboClean can be found on the Bricks platform, gobricks.com. Bricks has a variety of computational, machine learning, computer vision models. For the purposes of this demo, I'm just going to be talking about RoboClean and RoboFlat. See, as a logged in user of GoBricks, I have some capabilities on the left-hand side to help me navigate through this platform. The first one is data sets. This is where I can create a data set, for example, upload my point cloud data that needs cleaning for RoboClean. You can see I already have some data sets uploaded here. And then I wanted to show you the results page. And when I click on results, this is where all the results of my RoboFlat and RoboClean runs will appear once they're done. And from here, I can click on a result and then view the output, download it, download all the output, depending on download a specific file or download all of the output onto my computer. But I wanted to show you here what the step would be like. So once I've uploaded, I've captured that data using my 3D laser scanner, then I upload the data to gobricks.com and go to RoboClean, select Run Model. This point, I'm going to choose the data set that I want to clean. Select Next. Here, I can enter a name for my model run. And then I have a few parameters that I can set. I can choose the complexity of my cleaning. If I want it to really eliminate a lot of points, or if I want to be a little more conservative, I can slide that down to low. There's also advanced settings, so you can clip the cloud more precisely by setting up some parameters for the near distance from the scanner or the far distance from the scanner. You can also upload a DXF file that has defined boundaries that need to be excluded from the cleaning operation. And once you're done with that, you review your parameters and select Run Model. So once that RoboClean model run is done, you'll see it in your results section. For example, here is a small floor cleaning job that I did with RoboClean. You'll see it generates two different files. So what RoboClean is doing is it is classifying all the points in the file as either ground or non-ground. So if you want to use your RoboClean output in RoboFlat, you can use your E57, the E57 that RoboClean automatically generates. That has all the noise points, the non-ground points, classified points automatically removed. But we also, again, back to that flexibility, we're giving you the option of also outputting an LAS file that has both the ground and non-ground classifications in it. So that I wanted to explain those two different outputs. And then as a RoboFlat user, once I have run my file through RoboClean, It is very easy to choose the RoboClean, the outputted cleaned file um, in my RoboFlat run. So I would go to RoboFlat, click Run Model. You'll see here that I do have the choice to choose a data set that I want to process and analyze, or I can select RoboClean Results tab, and it's going to show me all of my cleaned files that have been already cleaned by RoboClean. So I can select a cleaned file, select next, and here you have um, a, a fantastic, very powerful parameters page that allows you to specify your testing standard, um, specific values for a variety of tolerances, flatness, levelness, and curvature. You can select attributes for your grid. And to make it even easier for your RoboFlat setup, you can save these parameters as a template and then just select the template um, and have those parameters automatically applied and auto-populated in these fields. So you don't have to re-enter all of these parameters if you're doing similar tests. Let's see. Once you've entered all of your parameters, you select next. You can customize your report, select next, click on Run Model, and your RoboFlat model run has started. And when it's done, you can download your file from the results page. I wanted to go back to the presentation if possible to show you the results of, and have James is going to share his screen in a second. I want to show you some results of RoboClean first, and maybe James, you can talk to it. I've got like a before and after if you want to talk to this slide.
Okay, thank you. In this slide, it's just a typical, data we've scanned and we sent to RoboClean that we've just clipped off most of the data and to send it there. That's why you're not seeing everything in the building. It's just kind of close to the floor. And if you see the dark blue lines on the screen, that is from the DXF file where we're going to want it to automatically RoboClean to go ahead and also automatically clip within those lines. It doesn't even try to clean that, it just simply clips anything in there. I think there were some large generators or something sitting on the floor, and we just wanted to clip that out in this example here. That's the before, and then the after, and it clips and it gets rid of any noise or any so again, on the low, medium, or high settings, you can make it where it's going to clip more aggressively. The point data is based on intensity return values, how far it is, and the angle that it impacts the floor, all kinds of different calculations that it runs through to clean the information. So it really depends on how tight you want it to clean is what it's going to do there. So you can see, number one, it clipped out the generator where it would have been sitting, and then also it's cleaned out some other noise and things from the floor. There's some gaps in this floor, but the project was closer to this generator. We didn't need everything behind it, so that's why you'll see some gaps in the clean data there. We didn't scan it very dense there.
Okay. And now I thought in this slide, James, we could talk about more of the RoboFlat output.
So this is a folder where I've downloaded the results, the output from RoboFlat, and just into one folder so we can kind of go through them. There's multiple deliverables. Again, back to what your client wants and what you need to analyze the output and things like that. The RoboFlat tries to get it where you have all types of different options to view your data. It does return a raw grid point of the floor at 300 millimeters, just where you can kind of have that separate data. The point cloud, of course, has many more points in it, but that's voxelized grid at 300 millimeters. So it's a best fit grid basically of elevations of the floor. And then there's some imagery, but those are ortho images that get embedded into the automatic DXF file that's produced. So it helps you with some backgrounds for your clients. Then there's the failure entities. Again, we typically tie our scans to the CAD file that our clients using for construction of the robotic facility. And so when these entities come back, every failure that happens on the floor, they get put into an Excel spreadsheet just as a simple XYZ plus what test it was that failed and what the threshold was and how far it deviated over it, so that a surveyor or someone with a robotic instrument could go out there with the theodolite, set up, put these coordinates in it, and actually stake out those failure points on the floor, making it even easier for your remediation team to find it. And sometimes we get clients that call us and say, hey, we want you to mark all these. You gave us 1,000 failures. We need to know where they're all at, and I don't have to go out there and pull a tape. Well, sure, we'll send a survey crew out there and we'll stake these out on the floor with that file there. And then further down, failure totals, that's just a real quick total. You don't have to look anywhere deep in the other spreadsheets. It's just right there. How many curvature failures did I have? What was my threshold? And how many failures did I have on that particular floor? Sometimes it's a real quick email to your client. Here's a quick answer for you, just where you'll know you're at. You don't have to look through a bunch of files. Sorry, I keep switching back to that file. There's the PLY file, which is the best fit mesh that was generated from all the points that was used in testing. So then again, back to your own analysis, you can look and see what was used to test the floor to make sure there's no issues that you wanted to bring up. Instead, just another way to where you can feel better about the product you're getting back. I'm a land surveyor, so I need to see all the data I can to review things to make sure we're right. And then the DXF file, there's a full DWG in here, but I'll tell you where that came from. The DXF file gets produced, has all the failures in it. The full XLS file gets produced, has all the failures in an Excel spreadsheet. And then there's the quick PDF report, which again, where she was filling out the information on the demo, it gets filled out at the top. And it's a real quick flatness failures, what your settings were, and then what your results were, and did you pass or fail those tests, and how many failed, how many passed, all those things. Just an overall, that's a quick curvature image, which is also inside the CAD file. That's how the floor curvature of the concrete looks, basically in a heat map type form, to help your remediation team find or tell how rough the floor really is. Ultimately, a real quick visual. And then this is a deviation map. Again, it'll be in the CAD file, but it's just an overall deviation. A lot of the floors only allow a certain amount of deviation, positive and negative, from your benchmark. And so here it will highlight automatically, hey, everything in blue is too low. You're 10 millimeters. You were only allowed 10 millimeters on this building, or 20 millimeters or something like that. So either side of that, it'll code it red or blue if it needs to be cut red, and if it needs to be filled, it's in blue. And the rest of it is just an undulation of the colors in between of the total deviation. So that report's real quick. You can just package it up and send it off again to the owners. The main Excel spreadsheet has lots of information on it. So on the left-hand side is a lot more. It's about what you selected, how many tests were run, what type of failures you had, what percentage of the failures the floor failed, and things like that. The first box here says grid elevation view. A lot of times, back to that deviation map we were just looking at, this is another way to look at it. This is like all the points on the floor and their elevations, and do they fit between the red and the blue line? That gives you another way to look at how many points really failed outside of the total deviation allowed of 10 or 50. I think this was 15 millimeters. And you can change that live to help adjust these. If your client, a lot of times will say, well, what if we move the benchmark up or moved it down? How much of the floor will fail? And as you do those on this sheet, it'll update the percentages of fail and pass, which helps give them an idea of what they could do to fix a floor without having to grind or a lot of times they don't want to fill, because fill will get torn out by the robots eventually. So they'll want to cut more, and they'll say, well, let's adjust the benchmark down. And when you do that, you'll get different percentages and cut or fill on that whole process. There's also a binning down here, a histogram that bins all the elevations, so you can tell, it's got 35,000 of the points. Again, these are voxelized points from the millions that were in the survey down to a best fit point, and then bend into where the elevations lie. Again, you could tell from this how much of the floor actually falls outside the deviation. Quick levelness and flatness test results, just to give you a green arrow, red, a little speedometer to break down the numbers above, just to give your users or the owners a quick results of where we're at. Down at the bottom, you'll see multiple tabs, and this is where a lot of the raw data sits, and also the Excel spreadsheet where all the information sits. That makes it quicker to use, quicker to go out and kind of apply the deviations and know where those are at. Now on the left hand side and the right hand and at the top, these column names, you'll see those in the CAD file that gets automatically produced to help you find these failures. And also these are the coordinates. So it's the CAD coordinates and also the column line grids to help you understand what's going on in each one of the different maps. So if we went to the finished floor, I'm sorry, the floor flatness heat map here, you'll see if I back out, the failures start getting colored as red and green or lighter green and things, and you'll start getting failures on this. And as you zoom into those, because this is thousands and thousands of points measurements, you can zoom in though and see what those deviations are and also what their grid location are. So you can kind of get all the answers you need without ever opening up a CAD. If your team doesn't want to use CAD, they just want to use Excel spreadsheet. All that information is embedded in here. These are floor flatness, floor curvature, floor levelness tabs. All this information is laid out the same as your CAD coordinates. And then on the right hand side, the raw data. The actual raw data that was used in the product, so that you can always have that as a backup of where all those things were generated from. If we switch over to the CAD file, it comes out as a DXF, but everything's generated for you. The curvature map I talked about, the what you see right this second just happens to be on top. The deviation map, then all the failures also are all generated, as well as a legend, which is has each one of the tests, how the test was run, a deep explanation of those tests, and also the symbology that'll be on the CAD map that represents the beginning and the end of the test. That's a circle here in this case. This is the levelness, and then the line that's going to be drawn at every one of those tests. And then if you look to the right, a full explanation. Hey, we collect 2 points on the floor. Those points are 1,000 millimeters apart. That is generated specifically from your input. So you as the user, hey, they need 3,000 millimeters between their tests, between the 2 points that are collected. Well, in custom, you can do that. And you can set that up in RoboFlat. It comes out, your legend is automatically generated with whatever numbers that you put in. So the threshold here was 9 millimeters allowed between these 2 points for floor levelness. Anywhere there's a failure, you'll get the beginning and end point marked with a circle and a line drawn between them. So then that'll be on the CAD file I'll show in just a second. But each one of these are broken down. This is the floor flatness concave, the floor flatness convex, shows exactly how the floor is being tested. Again, a deep explanation of how the math works. And then also the floor curvature looks like flatness, but it's a much longer test. You'll see here, this is 2 meters long. And the floor, in this case, the floor flatness is 300 millimeters. One is just for roughness, bumpiness of the floor, and the other one has deep curve testing, is what those are about. Lots of different specifications. So also in this, it's fully layered. So everything has, the FC is all your floor curvature information, the FD is the floor deviation, the map I was talking about, the FF is the floor flatness, and the FL is the floor levelness. So that makes it real quick. It took me, it probably took me 10 minutes to put together this, just to pull that information out, stick these different model spaces into my CAD file, and then turn off the layers in each one of the displays so that I have them broken down into 5 model spaces that I could plot and send on to the client right there. And this is the deviation map. Again, what we just saw in the PDF is here in CAD, plus contours, because it does produce contours in whatever setting. Again, back to RoboFlat that you choose. You can choose the contour interval, and that, of course, will help your remediation team and also the owners understand just how bad that floor is when they're looking at steep contours like that. This deviation map's not showing a failure, but it's testing for overall plus or minus from a certain benchmark, and also showing the contours. But if we go back and we want to look at the flatness, that deviation map is turned off, and the grid lines, let me go up here top left, the grid lines are drawn, and those grid line names again reflect back the same exact names that are used in the Excel spreadsheet. So each one of these grid lines are what were tested, because in this case we said, let's test every 300 millimeters. We want to test the full flatness test every 300 millimeters in both cardinal directions, or all 4 cardinal directions from those points. So here we do have a failure. And we can go back to the legend to see what type it is. And once you get those in your mind, you can learn them. But this is a convex failure, and it drew a red box at the beginning and end of the test, and also a line between them. And that's how the remediation teams will be able to use this in a PDF, if you wanted to print it a PDF, to be able to find these failures on the floor. And also, it gives you the cut back to spec. So this exceeded threshold by 1 millimeter in this case. So they've got to cut that by 1 millimeter. And across the floor, you'll see all these failures. There are floor flatness and floor levelness. I'm sorry, floor flatness, concave and convex failures. And these will be concave. So they're saying fill 0.6 millimeters to get back to specifications. And of course, if you wanted to, it's easy enough to turn on the contours on this model space also and deliver those. A lot of times we'll have those on when we deliver each one of these different model spaces, so that the remediation team can understand better just what they're looking at the cutter fills, and also why it's doing that, what the floor is doing. And these are the floor levelness, which they have the same cutter fills for all the floor levelness, and then the curvature the same. We'll have the curvature. In this case, we produce the cut on the high side of the curvature. I'll show you why that is in a minute, but also the slope of the incoming failure. So it gives the remediation team another way to look at how to remove this issue, to get rid of that issue. And if we go back and look at the curvature map, I'm sorry, the curvature legend, it shows that we collect these 3 points on the floor, and then the cut is placed on the high side, because you try not to fill on floors. Robots don't like fill, they'll tear it up. But so how can you remediate this? You bring the high side down to try to get rid of this bowl in the floor and feather that in. That's what the remediation teams want to look at. And so that and that's how they'll go back. So the cut's there, and then those slopes are published on each side to kind of give them a hint of just how steep that failure is. And one quick thing I meant to go over just real quick, just a better feel for this. A typical floor that we've cleaned and now we have a mesh of, and then on our curvature and levelness, in this case, we're doing 1,000 millimeter grid for each one of our test spots, and the 300 millimeter grid for each one of the test spots on the flatness. And from there, if we zoom in, this is the curvature, I'm sorry, that's the levelness, and you can see 0.2 and 0.1 shown here on the grid. That's the 2 points that are collected, and that's collected all the way across all these grids, 0.1 and 2, and measured for that threshold here, the 17.5 millimeters. And then the curvature, same thing. We're going to do the points 1, 2, and 3, just like the diagram shows, and those go again back on that 1,000 millimeter grid. Now you don't have to have the same grid as you do spacing between the points. You can have 1,000 millimeter grid. I want to test every 1,000 millimeters, but I want my points 300 millimeters apart. Well, they can do that. It's fully customizable, so you can do anything you want. But here's the flatness, the concave and convex flatness. It collects the 3 points on that 300 millimeter grid and runs this test for that threshold. So I just want to make sure it's just kind of a little bit better visual of what those points are being collected on the floor. And the entire grid gets covered with those points and run through this testing. So I think that that covers really ultimately, I guess, a high review of all those deliverables and what we're doing with them and how we split them up into model spaces and then get those sent off. So any questions or anything? I'll pass it back to you, Catherine.
Thanks, James.
You're welcome.
Share my screen again. So I just wanted to summarize the advantages that RoboFlat and RoboClean are bringing to the industry. With these solutions, contractors can easily provide floor flatness testing with their scanning services. Robotic system manufacturers also can be rest assured that their systems are going to run on the floor with no issues. Because of RoboFlat's such detailed, advanced visual output, concrete remediation teams can easily locate the issues on the floor with RoboFlat outputs, and building owners have the peace of mind knowing that their floors have been built correctly. Again, with both RoboClean and RoboFlat, it optimizes this otherwise multi-step a time-consuming process, eliminating a lot of pre-processing steps, freeing up computers so that staff can work on other tasks while the data is being processed. We also have a resource center that has a lot of information about 3D laser scanning and floor flatness analysis. And we have a very active LinkedIn presence as well. And we encourage you to follow us on LinkedIn. You can scan that QR code that we have on the slide here to start following and getting more updates on RoboFlat.
Thank you. And then also another question that I usually receive is the cost, or how to start. What will be the initial cost would be for RoboFlat and RoboClean?
Okay, so I do want to say that both RoboFlat and RoboClean, like all Bricks models, come with a free trial. And that free trial allows you to upload your own scanned data, floor data, have it automatically cleaned, have it automatically analyzed for floor flatness and levelness, and with no credit card required. So that's a huge benefit and a great way for you to evaluate these solutions to see if it works for your particular use case. We have, in general, for the pricing, we have both a subscription model for RoboFlat and RoboClean, and we also have pay-as-you-go options to give you the flexibility you need to suit your specific business case.
Thank you, Kathleen.
Okay. Well, I think that is it as far as our presentation. So want to thank you all for joining. And certainly if you have any questions, actually, Jay, maybe you want to talk about
Yes.
how best to contact you.
Yes, thank you for sharing the slides. So if you have any questions, please reach out to us and meet me. My email is j.kwon@kci.com. And also I'll be reaching out to individually to find out what kind of work that you guys do, understand your current workflow, and see if there's any way that we could improve your workflow using our RoboFlat and RoboClean. So that being said, that's what I wanted to share. And also, if you want to try out, this is a free. Simply, you can create your ID and password from our Bricks website, and you can simply activate the license right away.
Thank you. Okay. Thank you all and have a great rest of your day.
Thank you.
Thanks. Bye.